ask you to turn off cell phones and stuff like that to avoid noise. I guess we can begin. So I'm Simon Software. I work for Red Hat, and about 2 years ago, we started thinking about this project called FreeIPA, and we actually got to implement it. So I guess the first question for everybody that doesn't know it already is, what is FreeIPA and what does it stand for? So FreeIPA stands for Free Identity, Policy, and Audit, and those are the three legs that compose our product. The purpose of the project is to make simple to manage a complex problem, and the problem is the problem of managing identity management and managing identities in an enterprise. The means are try to use as much as possible standard components, standard protocols, so that it's easy to implement because you use documented protocols, and also it's easy to reuse already existing components and clients in your organizations. And the target is system administrator for 7 to 100 years. And what we try to accomplish is to have a system that is certainly complex, but also easy enough to use that you don't have to be an expert in every single component of the system. But the next question is, why should I care about something like that? Well, the point is that every organization that is not a very small organization, like anything that is more than 10 users, need to manage users and resources inside it. So if you look at the IDM landscape, what you see is that so far, only proprietary software was available for organizations that need to do some complex identity management. Of course, there have been for many years, 20 years and more, single building blocks that were available, like MIT Kerberos, various LDAP implementations like OpenLDAP and other LDAP servers, all kinds of web servers, different kind of policy and auditing servers. But to be able to have a comprehensive and a complex system integrated, you really had to be an expert in every single of these components. And this kind of expertise is not that common. While there are probably many of you that really knows how to manage one or many of these systems, being able to really manage them all in a way that can be easily applied to an organization that has multiple sites or multiple administrators is not easy. And indeed, it's never common. When I go to enterprises, I find that I use various proprietary products for that reason. They cannot trust one or two administrators to bear the load of the whole organization, especially if it's very big. So they do things like using, if they are kind of a Windows shop, today they tend to use AD, Active Directory. They use NT4 domains or eDirectory before. If they've been mostly Unix shop, they may still be using CA, Trust, all these kind of products. And the problem is that these products basically hold the keys of your organization. They have the very entry point. They have the user identity. They have the credentials. So basically is a very effective method to lock you into their business. So if you want to have a fully free environment, you actually need also a free identity management system, so that you can have not only your free servers, but also a completely free environment where you use them. And I believe a lot in security plus freedom. And by freedom here I mean free software, open source, you can inspect it, but also being able to switch to someone else if you are not satisfied by the security that your current security provider provides you. When you have a closed source solution, it's very difficult. It's extremely difficult, actually, to try to move something else. You're basically completely at the mercy of the organization that provides you that solution, because basically every single machine in your organization is tied to that solution, and try to change it on the fly it's a very hard task. So let's try to dive into what is the identity management problem. What we faced when we start this project were basically more or less these needs. We needed a single source for identities, because duplication is usually confusion. We came from a situation in many customers where people basically used to replicate the user from server to server to server and tried many ways to keep them synchronized, especially in the Linux space. Some organizations used NAS or NAS+. Very few used LDAP. And the reason for not using this system were depending mostly on the history of the organization, but some felt that having to depend on an external network services was not trustworthy enough at the time, or was too complex, or was too fragile. The second problem, or the second need, is single sign-on or single password, which are two quite different things. By single sign-on, I mean you don't have to put your password anywhere. So you can authenticate on your client machine and go and connect to any single machine in your organization without having to provide your credential anymore. While single password is, kind of second class or fallback position, where at least you have the same password everywhere, but you still have to provide it on every server or on most of the servers you connect to. Now, to achieve single source of identity and single sign-on or single password, you also need a single data store for identity and reporting, because you need to be sure that everything is working as you expect, and you need to be able to report what's going on in your organization. Once you spread authentication or identity in the whole organization, you need to be able to know that actually your machines are in compliance with the organization policies, that when you change a password somewhere, the strength is controlled so that you don't use a too common password, or that the machine that's actually inside of this network is actually reapplying the policies that come down from your network. And finally, you want a single point of management. You want to have a comprehensive view. You don't want to have multiple systems you have to touch just to create a user identity. You don't want to go in one place to create a user and give it, for example, its POSIX attributes like the user ID and group ID and stuff like that, and then go to another system to set the password, and maybe another system to set some other attributes of the user or preferences or the policies. You just want to go in one place so that you can see everything about the user in one single comprehensive view. So what are the implementation problems to achieve that? So one problem is either synchronization or integration, where when you have two distinct components that need to be synchronized, in some organizations that want to use both Windows and Unix, for example, there's a problem synchronizing the users on the Active Directory side with whatever you had on the Unix side. Another is distribution of data or credentials. When you have a system where you distribute or where you try to synchronize users, you have also the problem of distributing any change that comes in one of these systems so that the others keep being synchronized. You have single points of failures in some case when you have a system that is not able to replicate. And you also have the problem, again, of integrating interfaces, because you have different components that are completely, use completely different interfaces. You have a fragment system where you have to learn different syntaxes or different methods to change the information. So that's a challenge for organizations. So let's see what are the FreeIPA components that we decide to use to try to solve these problems. So the first one is the directory, and by directory I mean LDAP. There are other directories like NIS, NIS Plus that have been used in the past, but we found that they were not actually able to do what we needed to do. So why a directory? So we need a storage mechanism to keep the identities. These storage mechanisms need to be able to perform fine-grained access control. And why is that? If you look at the classic Unix or Linux authentication methods, you see that the data storage in the very basic configuration is the etc passwd file and etc shadow file, for example. So we have actually, even on a single client, two places where you have some information. And the reason is that the original mechanism, the etc passwd, was not able to have fine-grained access control on each and every field of the file. So when password attacks started to happen in the real world, people realized that having the password hash in the same file that everybody needs to access to see all the other information was not a good idea, because you were not able to prevent people from seeing the password hash. So the shadow file was created. At this point, we have already a synchronization problem. What happens if I change the password file and I forget to change the shadow file? Of course, there are tools to avoid that, but that was a problem. And that problem was also in NIS, because NIS is basically taking the file you had on your local machine and trying to distribute them again on multiple machines. But it didn't change how these files behaved. So in a system like LDAP instead, what happens is that you can set access control instructions for each and every attribute. So you can say, if you log in as an administrator, you can see or you can change, usually you don't see it, the hashes for your password. But the user that comes in can only see other attributes like the shell, the home directory, can't see the hashes of other users or his own hashes. We also need to be able to organize identity and our group relationships. That's why is that? Again, if you look at the traditional Linux system, you also have a third file, which is etc group. etc group contains group information. But again, there we have a synchronization problem, because you may create a user in etc passwd and not put it in the right group, so you may change groups and don't realize that the user doesn't exist anymore in passwd, etc. So we want a system where in a single tree we could have both users and groups, because groups are part of the identity of a user. A group may define what you have access to, what machines you have access to, or what resources on the machine you have access to. So it's really part of the identity. And if you look in the kernel, you see that actually the kernel have a structure where there is the user ID and the group IDs, and exactly for that reason, because the group IDs are integral part of your identity. Another good point is that we need to distribute information across all clients, and LDAP is really good at that. LDAP has been built exactly to distribute information and can do that very efficiently. It's very efficient from sources. It's less efficient for writes, so when they make changes, it's a bit slower, but that's not important, because the main task for an LDAP server is to distribute information. And finally, and that's to avoid a single point of failure, you really need to be able to replicate information on multiple servers, so that if your main server or your whatever server you usually use goes down, you can immediately connect from your client to another server and keep having information from the server. Other reasons why we chose LDAP is that it's a standard, although it's not a standard that can change, and indeed some implementation are less adherent to the standard that we would like, but more or less, at least for all the basic functionality, LDAP is quite standardized, and all the clients we know can connect to a random LDAP server without problems. It's extensible, both in the sense that you can extend the information that is tied to an identity, user, or group You just have to introduce some new schema, attach a new object class to a user entry, and you can attach new information to that user entry. And unless a client is very badly written, what happens is that the client doesn't mind if there is more information, because the way LDAP is done is that it's really part of the protocol that you can find additional attributes they're not interested in. When a client searches for some information, usually it doesn't always specify how to reach the entry, but also which attributes it is interested in. So that means that you can really extend the information about the user in the same place where all the other information is without having to create new information at the storage. It's also extensible in the sense of what operations you can do in LDAP. LDAP has indeed extended operations. So basically, you can customize and create new operations over LDAP if you need something that cannot be simply resolved with a query. And we actually do that in FreeIPA. And it's very flexible because of these reasons. So second part of the identity is usually authentication. They go together. You have an identity, you have some credentials. How do I use this credential to prove that I am who I am? And what we decide to use is Kerberos for a number of reasons. Okay. So we say that one of the things we need to do when you use an identity management system is try to provide single sign-on as much as possible. That allows you to provide services for a multitude of servers without having the user to re-enter his password again and again and again, which is something that is both annoying for the user because he has to basically stop his work and try to remember his credentials and re-enter again. It's also usually insecure because if you make the user think that it's normal to provide your password for anything you do, it's very easy to convince him to provide the same password to a server that is not under your control, meaning that it makes the user willing to give the credentials even to servers that are not trusted, which is bad. And Kerberos allows you to do single sign-on authentication. Kerberos is a ticket-based system where you basically contact at login time a key distribution center that will give you back a ticket, and that ticket basically allows you to get other tickets to access services without having to provide your real credentials anymore. And the good thing is that this ticket expires very quickly. Usually it's between 6, 8, 24 hours depending on the configuration of the KDC, which means again that even if someone can somehow get hold of your ticket, he's not able to use it for more than 8 hours, 24 hours, the time until the ticket expires, because there is never transmission of your credentials which are required to basically acquire a new ticket to go on and further use other people's credentials. Because of this, it allows also administrators and users to basically go from server to server. And through delegation, it also allows you, if you use something like SSH, to basically get into a server, delegate your credentials to the server, and from the server, connect to another one, and still carry on your credentials. And you can delegate again and again and again without having to directly connect to each service you need. So you basically can jump from server to server and carry on your credentials with you by just carrying your ticket granted ticket. It's a very tested standard. Has been developed for many years at MIT, and it has been actually implemented in basically all the identity management system around there. The most popular system that basically made Kerberos available to everybody is actually Active Directory, which is based on Kerberos as well. And their implementation is almost standard. They have some things added to it, but it kind of interoperate with the standard MIT Kerberos implementation. It is also to some degree extensible. It's not like LDAP where you can plug in whatever you want, but there is a still very active community around Kerberos. MIT also created recently the MIT Kerberos Consortium to be able to keep going on and develop MIT Kerberos. You can actually introduce quite easily new encryption algorithms. Recently, AES was introduced in most Kerberos implementations, and this is going completely away. But it's very easy to introduce new encryption algorithm, and the protocol is built so that it can actually provide the clients with a list of encryption algorithms that are accepted from the server and vice versa, so that basically clients and servers can negotiate the best encryption algorithm available at any given time. So we use Kerberos in FreeIPA. It's the predominant method to do authentication when you use a FreeIPA, but because unfortunately many applications still rely on a username and password paradigm, we also provide the ability to use LDAP binds, classic LDAP binds, where you connect to LDAP, provide username and your password, and authenticate it. But this is certainly not what we advise you to use normally. So back to the components list. Up to this point seems very simple. Basically, there are just two components. You have the LDAP server and the Kerberos server. And it seems like it shouldn't be a big deal to build something like this. But unfortunately, this is not all. As soon as you introduce Kerberos in an organization, you have to deal with DNS and NTP. One thing about Kerberos is that it's very time sensitive. Because Kerberos releases tickets that are available only for a short period of time, it actually needs to make sure that you're not using clock skew to try to reuse an old ticket again. So the maximum clock skew between a client and the server can be 5 minutes. So there is clients and server can have a slightly different notion of what exactly this moment is in time, but not too much. So what you really need in an organization is to introduce NTP, the network transfer protocol, so network time protocol, so that all the client servers in your organization basically are synchronized and they all share the same clock. The other components, is not strictly necessary, but actually for any real implementation you really want it is DNS. The reason is that when you use Kerberos to connect to a service and you want to authenticate to that service, you need to know what is the DNS domain name of that service. And that's because when you ask for a ticket, you need to ask the KDC for a ticket for a specific service name, because the name is part of the service principal, basically the identity of the service. So if you don't have a way basically to connect to a server using a name, you can't get the ticket to connect to that service unless you ask the user to provide it somehow, and that's something you don't want to do. So basically, it turns out that when you implement Kerberos, you want to have DNS and you want to have all the client and server registered in DNS. So when one client tries to connect to another server, it knows what is the other server name and can ask the KDC, please give me a ticket for that server. The client as well need to be taught how to basically use it. So you have to teach the client how to use LDAP to get users. You have to tell the client how to use Kerberos to get to log you in, and you have to tell the client where is the NTP server and where is the DNS server to use to be able to do both things. This also means that usually you want to connect the DNS and the directory. It might just be that you use host files on the directory in case you don't want to use a DNS server, or just that the client use the directory to store his own name so that DNS can ask the directory, the user directory as a storage. But usually you want to connect them so that each host is connected to his own name in the DNS. So when you create a new machine and a new service principal, you also can link these two things together. So the name of the machine is linked to the service principal of the server, and that's because again, when you look at the whole organization tree, you want to see that if each server actually has Kerberos connection or not in an easy way. So you want to keep everything in one place to connect all the dots. As soon as you start thinking about that, you also realize that you have to have a method to configure the client, at least for the very basic things like where do I connect to get information. Partially that can be resolved through DNS and SRV records, so that in DNS you can tell where the directory and where the Kerberos server are, but you also want to provide the client with at least the basic security policies it has to use, whether it can accept a connection, authenticated or unauthenticated, whether it can accept a connection from a specific user for a specific server and stuff like that. So as soon as you start having the network paradigm, you really want to have a method to configure the client as well in a centralized manner. So when you change something in your organization, you don't have to run machine by machine, but you have an automatic distribution of this information to the clients. Some information can be downloaded from the directory. Some information still, at least in Linux systems, is really embedded in configuration files. So you need another method to get this information and put that into files. That's what we call policies. Another component that we think is important is web UI and admin tools. And the way we build the admin tools and the web UI is through a web server, Apache in this case, and an XML RPC interface. So basically, web server becomes a component of this picture because you need to manage the web server, you need to make the web server available to clients. And that means also you probably need a certification authority, because when you talk to a web server and you want to have a secure channel, usually you need an SSL certificate, a TLS certificate. So immediately you start having the problem that when you have multiple servers and clients, you basically need to make sure that the clients connect to the right web servers and not to man-in-the-middle servers that can spoof your connections. And that means you need a certification authority of some sort, or at least certificates from an external certification authority, so that the client can trust the SSL certificate without user intervention. And finally, once you have all these pieces, you really need a way to know that everything is running properly, that there are no breaches in the security. So you basically need an auditing system that can connect to all these pieces and report in a central location if there's something is not working correctly, or if there is penetration attempt or whatever, so that each single piece can report in a central place where you can basically collect and compare data from all these systems to know that your solution is working properly. Okay, so what are the actual components that we decided to use inside FreeIPA? We start with Fedora Directory Server and MIT Kerberos. We added Apache on top with a bunch of modules that we use by default. Modern SS instead of Modest SL is used. NSS is the Nested Security Services Library, which is a very good SSL TLS library, which is used because it's also certified. It has FIPS 1, FIPS 2 compliance, and it's a library that is being used more and more inside Fedora. There is actually a project to push all upstream projects to try and use NSS instead of OpenSSL or other solution like TLS. We also need mod out Kerberos to be able to use Kerberos authentication in Apache, and we will see why we use mod proxy. For the web interface, we use TurboGears, and we also use Python because TurboGears we could use Python, but use Python also to implement the XML RPC interfaces. We also had to implement custom Fedora Directory Server plugins, and we developed a set of tools also in Python for the admins. And this is basically the stack you see on the server side in V1. On the client side, we use in V1 NSS, LDAP, and Palm Kerberos 5 on Linux. More or less all Unix systems have equivalents. And we basically use what is available on these systems. What we don't have, and that's in gray, is we don't have a proper CA in V1. What we do in the default installation is to create a self-signed CA and expose the certificate through the web server. It's not ideal. We don't have policies in V1, and we don't have the audit piece. So all the things you saw in the last slide basically the red pieces and the green one are absent. I mean, the green is self-signed, so it's not really there. This is the directory structure we use. Why it is important? Because even though LDAP tend to be very flexible, also need to have some conventions so that you can actually use the directory in the same way. One of the things you can see immediately from here is that you don't see the familiar OU equal people or OU equal group in the base DN suffix that you might normally see in other LDAP data implementations. We decided not to go that way, and we decided to basically put all the user and group information under the CN equal accounts subtree, because that way we could more easily add access control instructions only on one subtree and keep other subtrees like CN Kerberos or CN etc, where we put a lot of configuration outside of these ICIs, and make it simpler basically to prevent access to part of the directory where normal clients shouldn't have access. And these came handy immediately after V1.0 was released, because we found out that unfortunately Solaris does not support in 2009 RFC 2307 bis. RFC 2307 bis is what we rely on, because instead of using the very old member UID attribute where in a group you just name the user by name, we use the member and member of attributes where you basically put the DN of the user into the group entry. And unfortunately Solaris is the only one that is not able to read the information that way. So what we did is we built a plugin in FDS that basically create a virtual subtree called CN equal compact, and it presents the same information you have in CN accounts, CN groups, but with the old RFC 2307 schema. So if you have a legacy client, a Solaris client, a very old Linux client, some old AAX or HPX client that still don't support 2307 bis, what you can do is basically point these clients to use the compact subtree to find group information, and they can find group information in the format they used to. Okay, so besides the directory, how did we basically integrate Kerberos in the directory? As I said before, one of the problems is synchronization or integration of information. We wanted to avoid having a different database for Kerberos because we would have to synchronize that database with the directory. So basically what we did, we used the LDAP plugin of the MIT KDC, and we store all the Kerberos information into LDAP as well. And actually, we store the user credential in the user entry. And then we just use ACIs to prevent any other user or the user himself to directly access those credentials. Another piece that was necessary, though, is the password plugin. Because we wanted to allow people to also use classic LDAP bind, for legacy applications. We needed to make sure that the password hash in LDAP was actually represented the same password that you use in Kerberos, so that you can use the single password approach in that case. So basically what we did is rewrote IPA kpassword, creating a new kpassword daemon specific for IPA that basically rewrote any password change request on the kpassword protocol to LDAP and use the LDAP password operation. The same happens if you use directly LDAP password operation against the LDAP server. You go through the password plugin. The password plugin basically generates all the Kerberos material for Kerberos. When then you do kinit, Kerberos, the KDC basically gets that information out of LDAP, extract from ASN1 the secrets, and is able to authenticate your packets and give you back Kerberos TGT. Okay. So basically the directory is the source of all the information. We don't have a synchronization problem because the information is kept within all the user data. So if a user is deleted, also all his Kerberos material is deleted immediately. The Kerberos server will not be able to give, again, a ticket for a user that doesn't exist. We don't need to basically go back into the Kerberos database and try to delete it as well. When a user is renamed the same, etc. So the other part is management interfaces. They are also completely dependent on the directory server, of course. As I told you before, we use 3 main modules in Apache, and that's because in V1, we had a problem with convincing the TurboGear stack to use Kerberos authentication. So what we did is to create basically a proxy approach where the authentication is done by a mod out Kerberos on Apache, and then every single query is proxied to the GUI, which is a process that runs only locally. And the GUI gets actually the Kerberos credentials, even though it's not able to use them itself to authenticate the user, and use the XML-RPC interface so that we keep ourselves honest. Everything that you see from web interface is the same thing that's used also from the admin tools, so that they all use one path only. You don't have to duplicate functionality, and you're sure that if you test something with one of the two, it's the same thing. So if you make something new in the web UI, basically you have to also create the command line utility at the same time. And we basically get the credentials into XML-RPC, and we use your Kerberos credentials that are delegated to us to connect to the directory server. And that's another layer of security, because basically it means that the web server doesn't have any privileged access to the directory. To be able to access any data in the directory, you really need to have your own Kerberos ticket. So when you connect to either XML-RPC or to the GUI, you have to provide your own user ticket. And that ticket, because we use delegation, is what is used to authenticate the XML-RPC piece to the directory. So it's not possible, it's structurally not possible for someone to basically hijack the web UI and try to perform administrative tasks unless you really have the administrator ticket. So you really need to be administrator before you're able to do anything like that. And yes, so let's go on because I have only 10 minutes. So this is the web interface for V1. Just wanted to show something. It's very simple, very basic. It doesn't do much, but it does the task we needed. Add, find users on the right, add, find groups, delete groups. Manage policy, which are just password policies in V1. We also have a self-service page where a user can change some of his own attributes. Again, because we have ACIs, we can allow a user to basically change some of the information that are in the directory. Like for example, you may say, I want to allow the user to change his own phone number so that other users can get an updated phone number without having to go through an administrator to change that information. But we want absolutely to prevent him to change his own group ownerships, for example, stuff like that. We also have, of course, a command line interface. There are a lot of commands around there, more than 20. And if you really are not satisfied by using abstractions, you can even go and use LDAP yourself if you know what you're doing. Although I don't think you really want to do that. You usually will break your own installation. But as you can see, this seems a very complex system. And we said we want to make it simpler to manage. Yes, the web interface can help. That's also the whole thing about installation. So what we built within the project was actually, for example, a whole set of install utilities for both for the server and the client. If you want to try IPA, and I suggest you try them, and v1.2 especially, all you have to do is basically install the packages, run IPA server install, and you get 3 questions. It asks you what is the real name for Kerberos, and it also suggests a default based on your DNS name, the DNS name of the machine. It asks you for a directory manager password, which is kind of the root password of the system. It's something that you don't use for normally, except for very specific operations. And then ask you for an admin user password. And the admin user is the default user that's created in the system that has a set of privileges, like it can create other users, can create groups, change policy and stuff like that. Once you do that, practically the job is done. The server is installed, configure, all the components are configured in the system, restarted, and basically you have a working IPA server that can immediately serve out tickets to the admin user or any user you create with the admin user. So we basically try to make it very, very simple to install without all the problems you have trying to understand how to configure LDAP, how to configure Kerberos, how do I configure any other service there. It's really as easy as that. So what would you end up to once you have done that? You have that core that now seems much simpler. It has all the components we described, but they are contained in that thing. And basically all you have to do is basically install a client. And there too, it's not that complex. We have a client install tool that will configure NSSL.pump Kerberos 5, and it works on Red Hat and Fedora, not other system at this moment, but it's very simple to configure just NSSL.pump Kerberos compared to what is to configure the whole server thing. And you can use basically any client that supports Kerberos authentication in the browser to connect to the server and do management through the web UI or through the admin tools. The other thing we needed to add is multiple servers. As we said, one of the problems is a single point of failure. What happens if my server has a hardware failure? If it goes down, the whole organization it can't work because my users cannot authenticate. And that's also one of the reasons we choose directory server instead of something like OpenLDAP. Directory server has a very mature multi-master replication. And it can basically replicate all the information at the attribute level on all the servers so that when you change something on any of the servers, that information is replicated immediately to all servers. It also meant that we could avoid using the Kerberos replication server kprop-d, and instead of having one master Kerberos server and many slaves, basically we have multiple master Kerberos servers as well. Again, setting up a replica is quite easy. IPA replica prepare run on the master generates a file that is encrypted, so you can safely transport it over the network. And you just get this file on the new server, you run IPA replica install, and you'll basically just do it. It will take all the information in that file, generate a new server, install all the components, and it's up and running. And from that point on, you have 2 servers that are replicating all the information. If you add multiple servers, you can also use IPA replica manage to change the replication agreements. So if you have 4 servers, you can use it to add a new replication agreement so you that have a fully matched replication. We test up to, and by testing in QA, up to 4 servers. They can replicate completely, even the other cross there. And you can use DNS records to basically spread the load among all clients. So if you DNS service records, you basically can tell the clients, this is the list of KDCs, this is the list of LDAP server, connect to any of them. And they will tend to spread the load around. Okay, that was version 1. And as I told you, it lacks policy and audit. So what do we have in version 2? Well, in version 2, we have also some few interesting things. The thing that I'm working at the moment is SSD, System Security Services daemon, plus an IPA plugin. That daemon is basically a client agent that is able to combine Kerberos authentication, LDAP queries, policy queries in one piece, do caching, do offline operations. These are all things you can't do with NSS, LDAP, or PAM Kerberos, which are a very bad thing, because if you lose your network temporarily, you can't get any more user information. So application may get stuck when they do a simple thing like get PW name, which asks for the information for the user. We are creating a policy infrastructure where we have a policy processor on the client, also called by the daemon, and we have also management interfaces for that. We are introducing host-based access control, centrally managed, and the rules are stored in LDAP, so that you can say user foo can connect to machine bar between 8 and 10 Monday to Friday, nobody else. Or even at the service level, you can say foo can connect to bar through SSH, but not to Samba or HTTP, stuff like that. We are introducing roles in V2. But that's a bit complex. Let's go on because I have very little time left. And we also have an audit daemon both on the server and on the client. A new web UI. As you see, we had to build a kind of hack in V1 where you have a proxy, stuff like that. We try to solve that. We are also trying to have a better user interface. So we have sessions with people that are expert in UI design to try to make it a bit better, a bit Ajaxy with more interactive and stuff like that. Although we keep the same code again to also provide all the command line stuff. DNS integration, it's another thing. We are working on a new LDAP bind plugin and GSSDSig to provide the option to do dynamic updates. A registration authority, which can connect a certification authority to request certificates, and other services in LDAP. So this is the picture of V2. It's not very different from the previous one, but you can see there are a few more things that we ask and a few more pieces in the core. Still, we try to keep it simple from the management point of view. Just one word on client machine identities. What we lack in V1 was by default having an identity for the machine, and that's very important because you want to really be able to use Kerberos also from the machine to connect to the server, to get data in an authenticated way, and you want to be able to, by default, connect to another machine using SSH and Kerberos without having to manually create a host principal and install it manually on the server. So we do that through the new client. Policies, we discussed them a bit. If you're interested, I have talk later on in the Fedora session. I will talk about this. And audit as well, 2 pieces. The client that collects audit logs, the kernel audit logs, syslog as well. You can use our syslog to send them. We will also have an option to use the NQP, which is a very interesting messaging queue protocol. Has a very good thing that it can do store and forward. So if your machine loses the network, it can store the logs temporarily. When the next one come back, you can send them. You can also have routing rules, so you can have an audit server that is interesting only on a subset of the logs, and another one that collects all them just for storage and stuff like that. And in fact, we have a server component that gets all the information from the client, uses Kerberos authentication to connect the client to server, so you have authentication, sign and seal of the connection, so you have proof that the log comes from the real client and stores them for later retrieval. And I have no time. I wanted to just show this diagram, which is the thing I'm working on. I will talk about this in detail into the Fedora talk section at 4 p.m. if you're interested in this component. I guess we don't have much time for questions, maybe one. Yep.
Two, actually. Windows integration and status version 2.
Okay, so the question is Windows integration and status version 2. That's a very interesting question. The problem with Windows is that they actually assume a lot of things from an authentication point of view. At the moment, we have a synchronization between FreeIPA users and Active Directory users. If you use Active Directory, we have on our wiki pages also instructions built by some users, very, very good instructions. If you just want to use the Kerberos side of FreeIPA to do authentication. The problem is that Windows will never connect to LDAP to get user and group information. So what you do in that case is basically you create a local user and you associate that user with Kerberos credentials. So you can get at least your Kerberos credentials. If you don't have a lot of interaction, maybe you have just a Windows desktop for some special purpose, then maybe having group and other information is not that important. You can use that method. At least you have centralized authentication against IPA. You can access services through Kerberos. But yeah, it's kind of limited. And the plan is to work with the Samba community to basically integrate FreeIPA Samba 4 at some point. But that will take a lot of time at this moment. Version 2 under development. I have a number of pieces of this thing you're seeing here. We initially tried to shot for release early this summer. I don't think we will make it. It's really a lot of work to add other pieces, but we are confident that we can have at least the very basic pieces working sometime by the summer, so we can start testing stuff. In the master tree, we now have all the new web UI stuff, the new command line utility stuff that Jason has built. And we have the SSD tree, which is going on. The policy work has started as well. We have some stuff there. We have a basic daemon that's being integrated. So yes, we are progressing, but thanks very much. Thank you.